Hello, everyone. It's time to introduce to you this book, Federico Faggin's Irreducible, one of the most important books I've read recently. And I'm going to do a quick review of that and tell you why I think it's really, really important. Hello, my name's Patricia Warby, PhD. I'm an ex-research scientist, now trauma release practitioner, but I'm very, very interested in the world of quantum mechanics, quantum physics, the nature of consciousness, and all of those things. And you'll find a lot more of this on my channel, as well as health and healing, emotions, and trauma release. So it's a very broad church, this channel, and I encourage you, please, if you like my content, to please subscribe. Okay, so Federico Faggin, who is he? Well, he's a physicist. He also invented the microprocessor. I don't need to go into his full resume because it's well documented elsewhere. But he's certainly been in the business of thinking about intelligence, computers, mind, consciousness, and how we recreate that. And I think this book is the summary, sum total, if you like, of his life's work, really. Now, the thing that sets him apart, though, is it's not just theoretical for him. He actually had a fundamental transcendental experience in his 30s, I believe it was. And I think he was on holiday. He describes this in many videos. You'll see him interviewed where he talks about this. And I actually connected with, he believes, the fundamental consciousness of the universe and was given this information. Now, I know a lot of you will be skeptical about anything like that. And certainly, the old me would have said impossible. But I've had some extraordinary experiences myself as an adult now that can't be explained, if you like. You could say it's a neurological blip, and many people do. But I think essentially that we're onto something here. And maybe if Federico's right and we are moving into a new understanding of who we are and what we're here to be, then I think it's a very exciting time to be alive. So I made some notes because this book is dense, okay, and not one to be taken lightly, probably one to be reread at some point. Certainly in making the notes and going back over some of the information, I was like, oh yes, there was so much in here. It's not an easy read. You wouldn't sit down and maybe read this before bedtime or get through it in a weekend. I don't think so. It's taken me probably a month and a half, and that's unusual for me because I'm an avid reader. But it's so full of information, and some of it, not beyond me. He's managed to make it understandable. Maybe the last third of the book I did struggle with I space, P space, and C space, things like that. There's sort of information processing and computing theory understandings. That kind of lost me a bit. But where I think it's really, really profound is in its understanding of life and biology. And some of you may know, I recently recorded a video on living systems. I think it's this book, Understanding Living Systems, by Raymond and Dennis Noble, the brothers. And I think it's very complementary to that, actually. But of course, it's going more into the quantum reality of physical systems. So let's begin at the beginning. Okay, the fundamental nature of reality, he says, is quantum. What do we mean by quantum? We mean at the very fundamental level of the universe, nothing is determined. It's probabilities. It's not physical. It's not something you actually can say is an object. They're particles come in and out of existence all the time. They emerge from a field. So they don't appear as objects, as classical physics said, billiard balls bumping into each other, but as excited states of the underlying field in which we are embedded. And you cannot, in quantum physics, determine both the position and, say, the speed of a particle. We can only predict probabilities. So it's an indeterminate system. And indeterminism is an irreducible property of the nature of the universe. And I guess that's why he called it irreducible. That sounds like a song. Anyway, so our measurement, what's really interesting is that when we, as human beings or our machines, make a measurement of some aspect of the universe, it changes the probability. Okay. So we are actually interacting at some level with the particles that exist. So we're embedded and interacting with them. We're not separate observers. And indeed, I think we need to get away from the idea of the observer. It's a participant relationship. Okay, so we're co-creating, which is an extraordinary leap when you understand that. So your thoughts, the feelings that you have, the actions that you take all have long-term consequences for the nature of the universe. It's called the butterfly effect, actually. A butterfly's wings flapping somewhere distant on part of the planet has an effect on the weather at another part of the planet. May sound odd, but that's something that has been observed. So, okay, so the other thing, quantum particles, all right, it's a very difficult word because particle makes you think of a solid object, and they're not. They have no boundaries. All right, say, take an electron, for instance. It cannot exist without the field from which it emerges. All right, they are one and the same thing. They're not distinct entities. The part cannot exist without the whole. It's neither a particle nor a wave. It's another thing entirely. That's actually a direct quote from Max Lederman. He uses a lot of quotes in the book, which I think is generous, because he's saying, and it's not just me saying this, it's a set of properties that emerges from the field without detaching from it. Okay, and that exists in life too, in living organisms. And the other property of quantum systems is entanglement. All right, so things that have been connected at one point never lose their connection. And so you can, two electrons that have once emerged together, if you change the spin of one, you instantaneously change the spin of the other. And it doesn't matter how far apart they are. It's absolutely irrelevant. Distance, space-time is not part of quantum reality. Okay, that's how we perceive reality. I hope I'm not losing you here, but this is really important to understand. Okay, so the entanglement kind of demonstrates something about the nature of reality, doesn't it? That there are far-reaching consequences everywhere from every action, from what we call local here together in the same space-time reality to non-local, something that happens instantaneously elsewhere. Very hard to explain these concepts in words. Okay. So we are actually interacting with the universe that we witness, as I've said, co-creating. In fact, we are the universe. How about that? We are one reality. And the physical world, therefore, cannot be divided into parts. It is a part whole and a whole part. You can't divide them. And so we are participants, not observers. That's John Wheeler. And this, of course, relates to what I do in life, which is I work with the mind and the body. I use something which I call mind-body medicine, which considers the mind and body as one. You see, it destroys that idea that they can ever be separate, because they're not only one with each other, but they're one with the universe in which they've evolved. And you may say, well, surely we can describe the universe with rules and logic and constants. But physics and mathematics, which I've argued in my book, The Mystery of Number, that mathematics is a fundamental description. It's not a representation of reality in the sense that the maths that we write is reality. It's a description of our way of conceptualizing or thinking about reality. And it's very, very useful. It's enabled us to create machines, computers of great complexity. And we're at the point at the moment of a potential AI explosion, and with all the ethical considerations that has, that AI is going to take over the world and machines are going to take over us, and which is a huge amount of fear mongering, I guess. There are going to be some fundamental shifts as we are released from doing more mundane tasks. I do believe that. But one of Faggin's primary arguments here is that machines are not the same as living organisms, as humans. And so the human mind is not reducible to an algorithm. But while we're at the subject of brains, the world we see is limited by our perception. You may be familiar with the fact that the electromagnetic spectrum, the visible part of the electromagnetic spectrum, is tiny compared to the full amount of electromagnetic radiation in the universe. And so we only see a tiny amount. So our perceptions are really, really limited. And therefore, our description of reality as we perceive it is a form of simulation, determined by what our brains can handle, what our brains can perceive. And that, again, is another quote from Heisenberg. So it's indeterministic. We can't determine how one small change here is going to relate to an effect there. And that's because small changes in the initial conditions that you start with make large, unpredictable changes in outcome. And this is chaos theory. And it began it began studying the weather and trying to predict weather systems. And what was found, in fact, Mandelbrot did a lot of work on this. You know, you've probably seen his images, his fractal images, but he started working on weather systems to try and find if he could determine the initial state of a system, could he then predict the outcome? And he found that he couldn't. And various theorists over the years have kind of found that because a complex system has its own kind of determinism and it's non-algorithmic or repeatable, all right, you can't copy it, you can't repeat it ever. It seems to have a life of its own, let's say. And so we now know that complex systems can't be determined, okay? Computers, on the other hand, are deterministic. You know, we start with a set of conditions and we program it to have a fully repeatable final outcome depending on the algorithm that a conscious being, usually a human, designs. Okay, so, and that's why Faggin believes that computers can never be truly conscious in the same sense as we are. Ethical issues, for instance, can never be computerized because they require a degree of lateral thinking, of feeling sense, connectivity, comprehension, let's say, which takes into account many, many variables which can't be made discrete, you know. So when living organisms have to encounter a novel environment, they have to take so many factors into account and determine a new response, which will either work or it won't, but they'll learn from that response. And in many ways, you could say our childhoods were those kinds of learning environments where we're meeting novelty all the time as children. From the moment we're born, we're finding new experiences and having to make sense of them. So a computer can learn, there's no doubt about that, and we've designed computers which self-learn, but it has to be reprogrammed, okay? And there has to be still, at this point in time anyway, a human intervention for that programming. And, you know, if you compare that with a living system, the living system recreates itself on the fly. It does so while it is carrying on the program. And that we don't have generally many computers that can do that. It's very limited. We have to turn it off to reprogram it, or we have to limit its activity in order to create a new outcome. And the only way that happens in the living system is actually when we die. And that's an irreversible change occurs that can no longer be repaired. Okay, so that's death. Now, you could argue, of course, that consciousness continues after death, which I do firmly believe. But the living system itself, the physical expression of that living system has gone. And so this dynamism, this creation on the fly, is something that really distinguishes living organisms from machines. And so we are not machines. We have some factors that we're able to take into account. We have this ability to reproduce ourselves according to novel inputs that really is not possible for machines to do. And I love this quote. So life is like a flame that reproduces itself. you know, and I would add to that at all scales. All right, so whether from the tiniest subatomic particle to cells to living bodies and to the universe itself. So, and there's no distinction here between hardware and software. We're both. You know, the interactions of atoms, molecules, and ions within the cell is a dynamic process by which quantum processes actually control this to reach near 100% efficiency in some cases, like in our mitochondria and in chloroplasts. Mitochondria create energy in our system. It's a quantum interaction with light. It reaches near 98% efficiency, which is completely impossible. We've never, ever created a machine that's that efficient. And chloroplasts, which create energy from sunlight, they create sugars from energy, is also a highly efficient process. So we do have some differences between machines and living systems. Now, up till now, physical systems have been described by the movement of chemicals, biochemicals in the body, molecules which sort of collide and have enzymatic reactions. I mean, this is what I studied, biochemistry. And there's undoubtedly the case that happens, but it's the slowest form of information processing, and we've focused on it. And we've set our medical model around biochemistry. In fact, when you study medicine, you do 2 years, or is it 3? Certainly 2 years of biochemical study before you do medicine, because it's considered the basis. But actually, if you think of it as the slowest form of information processing, we're missing a trick here. And that could be why drug regimes, pharmaceuticals are very blunt instruments when trying to change your health. And they undoubtedly do work, but they're the slowest form of information shift. And we're ignoring, at great peril, the importance of biophysics. Now, I talked about this in a previous presentation I did for the Awakening Heart Collective. I'll include the description below. In the description below, I'll include the link. But it's really important to understand that biochemistry has taken us down a false route, if you like, in terms of altering living systems and creating health. As we've ignored the whole aspect of electrons spinning. We tend to think of them as little billiard balls. Phonons. Who's ever heard of a phonon? Okay, phonons are quantum sound particles, very like the particles of light, which are photons, right? Don't get them confused. Phonons, sound, photons, light. These are all more important, but we actually know very little about them. We're only just beginning to discover that through quantum biology. In my book, Life Illuminated, I did actually write a lot about this because it was such a revelation to me, who's gone through 2 degrees of study that never mentioned biophysics at all. And so actually looking at the wave resonance structure of organisms is also really, really key. And as I've said, they're particularly important in mitochondrial and chloroplast function. And mitochondria are, without those, we can't survive. They are the batteries of our cells. And they also do a lot of sensing of our environment and information exchange. And without chloroplasts, plants, we'd be dead, because that's primarily how we get our energy, is by eating plants or animals who eat plants. So we have a constant flow of what he calls live information, okay? In living systems, information, matter, information, energy, which is all one thing, is constantly evolving itself. There's no fixed boundaries either, even at the cellular level, because the cell membrane, which in diagrams you're used to seeing as a double line, it's a bilayer, is not a definitive line, okay? Because the molecules are moving in and out of it all the time. And so even the cell membrane is dynamic. It's opening and closing depending on environment. The cell changes itself at every instant, and so do we, all right? Just by the way we conceive of ourselves. As I've mentioned, the thoughts that we think, the emotions we're feeling means that we're a dynamic system. What we have that sets us apart, I think, he identifies two things. Comprehension, all right, that we take information and we're able to digest it and come up with novel solutions. Comprehending, my belief is that it comes from the Latin to it's something to do with the hands anyway. It's taking something and holding it and, I guess, processing. Computers can run multiple algorithms, but they can't dynamically interweave, and that's what we do. The other thing that sets us apart is curiosity. Curiosity is a very important element of being human, all right, because it enables us to ask the question why and how might we adapt to novelty. And indeed, it's one of the most important things to keep alive in yourself if you are feeling less than healthy, all right? If you have anxiety or depression, or you have long-term chronic pain or fatigue states, getting into curiosity is one of the ways in which we break the anxiety cycle that says my body is broken and it's betraying me. That's another subject altogether. But it does distinguish us from machines, which, you know, are very limited in their ability to pull in different information streams and come up with novel solutions, because they're non-algorithmic properties, both of those, comprehension, curiosity, that arise within a conscious entity. That's us. This conscious entity then supervises, it sort of oversees the physical aspects of our functioning. So again, you know, what you think determines how you feel, which determines how your body reacts. You know, you've all felt wonderful because something good has happened to you, and your digestion settles down and your heart rate is really lovely and you feel great. You know, if you're in fear or threat, everything physical falls apart, you know. So we know that our consciousness, the state of our consciousness, our awareness does interact with a physical aspect of our being. And the thing about us is that we do know we know that we do not know, right? And so when we meet something that we do not know the answer to, we mobilize ourselves to discover it. And that occurs also at bacterial level, you know. Small little organisms also will make attempts to discover what they do not know. And so a global unconscious perspective that seeks to know itself is something that's present in us, but it is not us. And he calls this a Seity, which is a completely new word to me. It's a sort of independent overseer, which he believes is present in the universe, that kind of creates us to do the work of self-knowing. You could call that angels, you could call it beings, you could call it aspects of God. He calls it a Seity, and a knowing. Intentional behaviour, which we might call free will, are intrinsic properties of living organisms. And that's a really important understanding. There's a feedback and feed forward system that allows self-learning, and we can determine whether to approach or withdraw and what actions to take. And obviously that depends at what level of intelligence you're at, whether you're a paramecium or a bacterium or a human being. But there's a lot of research now showing that free will exists, or agency exists, in even tiny organisms. See the work of Nick Lane for that. So essentially, life as we know it is both quantum and classical. Classical referring to, you know, molecules having these sort of chemical interactions. And so therefore we're a mixture. Of course, you can't deny that there is a physical nature to the human experience. but it's all determined by the consciousness of that organism and the larger consciousness of which the universe is composed. And, you know, his theory, therefore, is the end of what's called reductionism, seeing living things as simply composed of parts, and that the quality of the organism is dependent on the way that the parts are organized. It's far more than that. And consciousness actually emerging as sometimes it's considered to be a function of brain neurology, you know, is being largely disproven. It's what's called the hard problem of consciousness. Because although we can say, well, we have neurology going on in our system and it might be able to create nervous system electrical signals, nothing really explains the feeling of experiencing something. And that is what scientists call qualia, the feeling of experiencing, because this occurs inside us. It's an inner semantic or meaning-led space. And we don't have computers that can do that. For instance, the taste of a lemon, okay, the sight of a sunset, the color blue, are all experienced within us as inside experiences, as a subjective experience or feeling. And, you know, for a computer, you may be able to design a computer that can detect the scent of a rose, for instance, if it has certain combinations of chemicals. But there'll be no feeling inside the computer towards the sight of a rose. Whereas for us, we may see a rose and we may suddenly remember our grandmother's rose garden, or have a sudden wash of, you know, joy because a rose is beautiful. And we may describe that in words, but the inner experience is entirely ours. We can't share it. We can't copy it to anyone else. We can describe it in words, you know, and sometimes we do through poetry or art, where we may attempt to describe something that we're experiencing. But how do we know that another person, another human being, shares this experience exactly? We've no idea, because it's a private interior experience that's only accessible from inside us. We can't describe it from the exterior. Now, that's entirely impossible for a computer to do. And this is the hard problem of consciousness. How can feelings and sensations be explained by something physical like electrical signals in the brain? It's sometimes described as an epiphenomenon, which is a lovely word that tells you that we don't know. It just spontaneously arises somehow. Nobody knows how. There must be something fundamentally wrong with that model if it can't explain what we experience. And one way of overcoming that hard problem or that difficulty is that consciousness itself must be primary to the universe, and everything physical that we observe and interact with somehow is a locally determined or locally arising phenomenon. And it can't exist as itself and describe consciousness. It's got to be the other way around. At least that's his theory. It's not just his. Bernardo Kastrup is another person who, in fact, he's done a little quote on the back here. He's another, you know, physicist who truly believes, and he's designed a whole theory around it, that consciousness is primary. So there is a great deal of convergence now in at least theoretical physics that this may be the case. Now, I'm going to do another part 2 to this recording, because I've only really covered, I don't know if you can see, about half the book so far. And there's other stuff I want to come on to, but I don't want to make this video so long that people turn off. So look, if any of this sounds interesting to you and you want to explore more, I'll put some links in the description below, for some of the other videos I've done on the work of Nassim Harramein, for instance, Dennis and Raymond Noble, a little bit on Nick Lane's work, and lots of different books that I've reviewed over the years that talk about this mind-body connection. And please, please, if you like my content and you want to join the discussion, please subscribe and get in touch. I look forward to hearing from you. I can be found on alchemytherapies.co.uk and patriciawarby.com. Thank you so much. Bye for now. Bye.